Much like with your addition formula, you're expected to be able to apply your double angle formula to a numerical example. So this first example on the left should look quite familiar to you in the fact that it's got this triangle in it with a missing side. So when it's asking for the value of sine 2a, remember you can have a look at your formula sheet if you're not sure, but the expansion of sine 2a we now know is 2 sine a cos a. So in this triangle, we are given our adjacent side, so it's adjacent to the angle A, and we're given opposite. We don't know our hypotenuse, however we do know that we can use Pythagoras to find our hypotenuse. So to find our longest side, which is c squared, it's going to be the two other sides squared, added together. So c squared would be 9 plus 49. C squared is 58, so C must be equal to root 58. So our hypotenuse is root 58. We can then use that in our formula to help us find the value of sine 2a. So we're going to have 2 sine a, so remember sine of an angle is opposite over hypotenuse. So remember, this is your opposite, this is your hypotenuse, and this is your adjacent, as I've already said. So opposite is 3 over hypotenuse, which is root 58. And we can replace cos a. So remember that cos of your angle, so cos x is equal to your adjacent over your hypotenuse. So our adjacent is 7, and her hypotenuse is, again, root 58. Now we can simplify it. So remember, when you're multiplying fractions, it's top times top over bottom times bottom. So we've got 2 times by 3 times 7 gives us 21 over root 58 times root 58. Remember your rules for surds. If we've got a root of something times root of the same thing, we can get rid of the square root. So in this case, it would just give us 58. We then still need to times it through by 2. So at this point, you can go straight to simplifying. You can go down to 42 over 58, but I know that 2 and 58 have got a common factor of 2, so my final answer is going to be 21 over 29. So sine 2a is 21 over 29. For this next example, so it's given us a value of cos 2x, and it wants us to find the exact values of sine x and cos x. So in our triangle, we want to have x on its own. So the first thing we're going to have to do is find a value for x. If you think about that last example, or if you think back to addition formulae, you tend to get something like cos x equals 7 over 25, and you can apply that to a triangle. But because we've got this 2x, it makes it slightly different. Now, if you look at your formula sheet, you will have 3 different options for your cos 2x. We are looking to keep this as straightforward as possible, so automatically the 2 formulas that include a sine x can get eliminated. So the expansion that we're going to be using is that cos 2x, which is equal to negative 7 over 25, is actually the same as 2 cos squared x minus 1, and that's going to be equal to negative 7 over 25. Now, what we want to do at this point is rearrange all of this to get cos x is equal to something. That would then give us something that we can apply to our triangle. So by adding 1 onto both sides, we get that 2 cos squared x is equal to 18 over 25. So remember, essentially what you're doing when you're adding on that 1 is adding on 25 over 25. That's how I got the 18 on top. We can then divide through by 2, so cos 2x is equal to 18 over 50. 18 over 50 could also simplify to 9 over 25. We don't want cos squared x, we just want cos x, so we can square root both sides and we get 3 over 5. So what that means is that we have a triangle, and in our triangle, if this is our x, cos, remember, is adjacent over hypotenuse. So adjacent to that x is going to be 3. And our hypotenuse is going to be 5. Now, either through use of Pythagoras or by knowing your Pythagorean triples, we now know that our opposite is going to be 4. So when the question's asking us for the value of cos x, we've just figured that out as 3 over 5. And the value of sine x, so remember sine x is opposite over hypotenuse, so in this case it's 4 over 5, and that's both the values that we were looking for.